Okay, everybody. So in this video, I'm gonna go through an example. Professors, especially if your organic chemistry is tends to be the type of course that gets to be tested free response, or professors love these type of questions. They'll give you a huge molecule like this. In this example, this is a drug, lyrium. Doesn't matter what the drug is. They'll just give you a random drug like this. Not too complicated, not anything too fancy, but it still looks a little bit intimidating, especially if you're barely, starting off in organic chemistry. And they'll ask you a few questions based off of this drug. And so I just really want to walk you all through a few example questions pertaining to this drug right here. And we're going to see what the type of questions professors love to ask, especially in free response exams. So let's go ahead and take a look at that. And as I talk and explain the questions, I would highly recommend you all write them down. That way you don't forget them. Copy down, go ahead and draw down this molecule. I'll give you all some time to do that and write down the questions as I say them. So let's go ahead and get started with the first question. And the first question usually tends to be locate the stereocenters, the stereogenic centers, the chiral centers in this drug. So go ahead and let's go ahead and walk through this together, and let's locate the chiral centers. In this case, we're going to have only two chiral centers because there are only two carbons in this drug that are surrounded by four different groups. And the first carbon is this carbon right there. That is that first carbon. That's our first chiral carbon. That carbon is surrounded by four different groups, therefore making it a tetrahedral, aka a stereogenic center. Okay, that's also called an asymmetric carbon. Those words are all interchangeable. So that carbon there has four different groups surrounding it. The next carbon that has four different groups surrounding it was going to be this carbon right there. And that's the only other carbon that has four different groups surrounding it attached to that carbon. So this drug here only has this drug here only has two chiral carbons. Would this carbon be a chiral carbon right there, or this one, or that one? And the answer to that is no. Remember, those carbons are connected to two hydrogens, so each hydrogen would be a group, and because you have two of the same, then you can't have a chiral center there, because you have two groups that are exactly the same. So neither of these carbons would count as chiral centers. So in this drug here, in lyrium, you only have two chiral centers, and those are the blue dots that are located there. So I'm going to say here, two chiral centers. So two chiral centers. All right, the next question they'd love to ask is, after you've located the chiral centers, now designate those chiral centers as R or S. So let's go ahead and do that together. So let's go ahead and figure out whether these centers are R or S. And I'm going to start with the first one up here, up top. So right there, I'm going to start with that carbon right there. So that carbon is surrounded by four different groups. So let's go ahead. So what would be the first priority? So remember, we're going, if you still have not learned how to assign priority correctly, go ahead and look at one of my previous videos. I go in lots of detail on how to assign priorities. I highly recommend those videos, so please go ahead and look at those if you haven't yet, before you start this problem. But yeah, so how do we assign the priorities here? My first priority, remember, you're going to look at the atoms that are directly attached to that carbon, to that stereogenic carbon. You have to look at the atoms that are directly attached to it. You cannot look at the functional groups. So you must not look at the functional groups. Remember, if you go by functional groups, you're gonna go by atomic weight and then you're going to get it wrong. We need to go by atoms because we remember, in order to assign priority, we have to go by atomic number. Therefore, we have to look at individual atoms. So in this example, that oxygen in the hydroxyl here is directly connected to that carbon. So I have an oxygen there and then a hydrogen. Okay? And then going down, I have a carbon which is connected to a nitrogen. So it hits that carbon first and then it hits the nitrogen. So, and then obviously we have a hydrogen, but I'm listing these in decrease in priority right there. And then going up, we have a carbon. I'm gonna list it right there. So we have a carbon which is connected to carbons left and right, right? So before it hits that nitrogen or anything else, it's just connected to a bunch of carbons. So I'm gonna write it out like so. Okay, so then what would be our first priority? So our first priority is going to be the one with the highest atomic number, and so that's going to be this hydroxyl group there. Our second priority is going to be the one with the next highest atomic number, and we have to go with the nitrogen, because if you take a look at this, we have a tie here and a tie there. Now going to our second atom, we have a carbon here and we have a nitrogen there. So that's our tiebreaker. That gives us our second priority right there. And so that by default, this is our third priority. And this is obviously our fourth priority, because the hydrogen is always the last priority. Okay? Now we have a problem here. We can't assign RNS yet, because remember, the hydrogen needs to be on the dash. It needs to be in the back in order for you to be able to assign RNS. We can't assign RNS yet. We have to put the hydrogen in the back. And as I showed you all in the previous videos, we're going to use our foolproof method here. There's no reason, especially on an exam, there's no reason to risk trying to do this in your head and switch out the atoms. So we're just going to use our systematic foolproof method on how to do this. And remember, the way to do this is you're going to want to switch out the hydrogen and put it in the back. So which priority here is in the back? It's the first priority. So we're going to switch 1 and 4. So my first priority is now going to be over here. And my fourth priority is now going to be right there. All right. And so that's how we do that. And now the fourth priority is going towards the back. And now we can assign RNS. So I'm going to go ahead and do my little clockwise motion here. So that's going to be 1, 2, 3, 4, just like so. So just like that. And that is a counterclockwise motion. So that is a counterclockwise motion. And because of that, so we had S, right? But remember, we switched the priorities. Because we flipped the priorities, now we have to flip on our RNS designation. Because of that, in reality, we do not really have S. We have R. So you also have to flip the designation. So just keep that in mind. After you flip the priorities, assign RNS, whatever you get initially, flip that, and that's your final answer. So this is actually R. So that stereo center right there is going to be R. All right, so just bear with me here. I'm going to go ahead and erase this. All right, so I went ahead and erased all that, and now we're going to call this R right there. Okay, now let's do the next the next chiral carbon. And so that one is going to be a little easier because the hydrogen's already in the back, so we can easily just assign priorities. And after we do that, we'll very easily assign RNS. So the hydrogen's already here in the back, so that's my fourth priority. So what is my first priority though? So my first priority is going to be, so remember, we're looking at that carbon right there. it's directly attached to a nitrogen. If you go up and to the left, it's connected to a carbon first and then an oxygen. Here it's connected to a nitrogen first and then the hydrogen. So Cn beats, excuse me, no, it's not a Cn. So it's just an N. It's a nitrogen first, versus over here going up and to the left, you have C, then O. So again, you have N versus C, then O. So what wins? Does nitrogen win or does carbon win? And the answer here is that nitrogen wins. Nitrogen has a higher atomic number than carbon, and so that is going to be your first priority, followed by this one right there. That's your second priority. And our third priority is going to be down here at this carbon right there. Okay, so now we go ahead and do our clockwise motion, or our clockwise or counterclockwise motion. In this case, it's going to be 1, 2, 3, 4. In this case, it's going to be like this. So what is that? And that is counterclockwise. So by default, that is going to be S. So that, and again, we can do that already because the hydrogen was already in the back to begin with. So just bear with me. I'm going to erase all this. Okay, and I'm going to write it out right there. So we have R and S. So those, that's our R and S designation. Again, professors love to ask this on exams. And as you all have noticed, this took us about 10 minutes. So you really don't want to spend 10 minutes trying to figure out if this is RNS, which is, I really recommend you all just work out as many problems as possible so you can get as fast as possible with this. This should honestly take you no more than 2 or 3 minutes on an exam, because if it takes you as long as it took us, you might waste valuable time on this question, and you might not finish answering the entirety of the exam. So just again, I highly recommend you all going through multiple problems. That way you get really, really fast at this. So that's R and S right there. All right, so then moving on to the next question, and professors, again, because by this point they expect you to be really fast at this, so then they're going to ask you to draw the enantiomer of this drug, especially if you're taking a free response exam. This is a classic question. So draw the enantiomer of this drug. And in order to get this right, you would have to first correctly assign the RNS priority. And once you do that, then yes, you can draw the mirror image of this drug. So all we want is the mirror image. In order for us to do that, remember, we're going from we started with R and S, so that means that our mirror image has to be S and R. And this is a really, really, really easy way to do this, is you just simply draw your drug all over again. So this is all you really have to do, is you just draw your drug. Let's go ahead and draw this together. So just like that. And so what we're going to do here is we're going to flip some things. So let me go ahead and finish drawing this off. All right, so what am I going to do? How am I going to draw this mirror image? So all you have to do is flip your wedges and your dashes, and that is it. That's all you have to do. I guarantee you this is going to work. So as long as originally this nitrogen here was on a wedge, so all we're going to do is we're going to put it on the dash like so, and that gives you R. And again, put this hydrogen in the back like that. You have to show the hydrogen is on the wedge, and if you do that, then that gives you R. Remember, over here before it was S right there, and all we did was flip that. We flipped the wedge and the dash, and now we turned it from S. Now we went from S to R right there. So that's an R. All right. And so what do we do For the other part of the hydroxyl group, we're going to do the exact same thing. We are going to put this hydroxyl group here on the wedge instead, and then put the hydrogen in the back like so. And we went from R to S. So now that is S and that is R. Of course, you could always double check this by assigning priorities and then doing your counterclockwise, clockwise motion and figuring out if this is really R and S. But you're just gonna have to trust me. This is really, really all you have to do. So this this guy right here, this drug would be the mirror image or the enantiomer of the original moiety right there. So that is how you draw the mirror image of that drug. Okay, and again, these are classic test questions that professors love to ask on exam questions. Another exam question that they love to ask is they love to ask about the nitrogen, and they like to ask what is the hybridization of those nitrogens in this drug, and so because that ties in material from the beginning of the year, from the beginning of the semester, that you learned from hybridization, and so they can very easily ask, what is the hybridization of those nitrogens? And in this case, remember, so that nitrogen right there has a lone pair of electrons, and so does this one, and this one's going to be sp3 hybridized, and this one's going to be sp2 hybridized. Okay, and so well, if you have any questions about hybridization, go ahead and watch one of my previous videos on that. I explained it in really great in really nice detail. So go ahead and watch that. But yes, I just wanted to really quickly show you all classic exam questions on free response organic chemistry tests. Definitely practice a lot of problems. If you have any questions, go ahead and leave a comment down below. Subscribe to my channel for more videos of me working out problems like this, and I really hope this helped somebody. Thank you so much for watching.